Hey everyone, welcome to another BTM screencast. Today we're going over Chapter 13, Drainage, Waste, and Vent Segments and Sizing. So some of the objectives that we're looking to complete are the ability to identify and describe segments of a drainage, waste, and vent system, or DWV, recall the basic abbreviations of a drainage, waste, and vent system, size the various segments of a drainage, waste, and vent system, and understand basic conventional septic system operation. So to get started, we're going to look at the designing and installing a DWV system. It can be a complex and extensive process. It's not simple and straightforward. Pipe routes are a result of determining fixture locations, fixture requirements, codes, obstacles, and coordination with other trades, as well as company installation standards. So if you think about it, you just don't want to go and start drilling holes in walls and ripping stuff out, right? You want to be able to plan your run like we do, and then having a game plan, right? Following a blueprint saying this is where I'm going, this is what I'm doing, this fixture requires this one requires that, this is the location of it. Every plumbing fixture connected to a drainage system must be protected by a fitting or a device known as a trap. So here we go looking at the anatomy of a trap. This is what we're going to be doing. So you can see right here, this is, let's say that you have a sink right here. The sink is going to be flowing down into this. And we have this trap seal, right? And this helps keep the sewer gas from coming in. So as this goes down, this is where drains tend to clog. So we have our top dip, our bottom dip. And as we go up, here's the crown, weir, and it's flowing out that way. So the pressure actually takes this and then pushes the water up and over, but it leaves enough right here to keep that seal in place. So these are some of the major segments of a drainage waste vent system. The building drain, the building sewer, a clean out, stack vent, a vent stack, vent through roof, and a waste stack. So here let's check out a couple of them. So here we have the lowest horizontal position. This is the building drain, and this goes to the building sewer. And this is where the wastewater gets disposed. And you can see it, this is on the outside of the building. Cleanouts you'll usually see, sometimes they're in the interior of a building. On this diagram, they have it on the outside of the building. As we come up here, we have our soil or waste stack, our stack vent, and then our vent to roof right here. Here's our top floor, and you can see we have another vent stack here. This is the base of stack cleanouts, so for our waste stack, we're going to have cleanouts as well. Building sewers are the main pipe conveying sewage and wastewater from a drainage waste vent system to a point of disposal or termination, and we saw that in the previous diagram. The beginning of a building sewer is typically where a cleanout is installed with its connection to the building drain, but most codes dictate that the cleanout cannot be more than 10 feet 0 inches from the outside of the building. The building drain is the lowest horizontal portion of a drainage system and receives discharge from waste stacks and horizontal branches. Many codes dictate that it must extend at least 2'6" and a maximum of 10 feet 0 inches from the exterior of a building. The waste stack is the main vertical pipe that begins with its connection to the building drain and terminates with the connection to the stack vent. It receives discharge from all horizontal branches and must have a cleanout at its base. The stack vent is the vent for the waste stack, known as the stack vent, and begins at the highest branch connection to the waste stack. So if we go back to the diagram that we had, you'll be able to see where the stack vent is. It's a dry piping system, so this doesn't have any water in it. It shouldn't. It typically extends through the roof but can connect with the vent stack prior to terminating to open air. The vent stack, its size is based on numerous factors, including the total discharge load of the system and the length it travels, right? So the amount and the distance. A cleanout is typically required by code to be installed at its base. The vent stack can transition horizontally without requiring a relief vent. Like all horizontal vents, it must have adequate slope to eliminate moisture from settling and obstructing its airway. Right? So if you think about it, when we're talking about the vent stack, if it's coming out and it's horizontal and it goes up this way, it's okay if it's pitched like that, right? But if we have it where it's pitched like this, then any fluid that comes down here is going to sit right here, and we don't want that because then it'll prevent the gas from coming up through. It'll act almost like a trap instead of a vent. A clean out. All codes dictate that the base of every stack and the transition from a building drain and a building sewer must have a clean out installed. Sizing is based on clean out being the same size as the pipe when serving a stack, building drain, and building sewer. But some codes allow for exceptions for pipe sizes greater than 4 inches. So a clean out gives you easy access to clean out, right? Because a lot of times everyone's heard about sewers getting backed up. This is backed up, that's backed up. The clean out lets you get right into the place where a lot of times those things get clogged. Now we're going to look at minor segments of a drainage waste vent system. We have the branch vent, the circuit vent, the fixture branch, the fixture drain, horizontal branch, individual vent, loop vent, and relief vent. So before we're looking at the entire system, right? It was the entire house. And now we're going to bring that down. So it's going to be like one room. So the segments for a bathroom or a kitchen as compared to an entire house. So here we can see that we have different vents, and this is these are the minor ones. So when we come up, right, we already went over what this one is, and then we have this, it's venting to roof, that's one of the major systems. And then we have a loop vent here, your a typical clean out toilets. Here we have a circuit vent, a relief vent, which goes over, connects to the vent stack. Here we have a circuit with an individual vent, a branch vent, and that connects to the vent stack. Here we have a fixture branch, and this is a horizontal branch coming through. And of course we have the fixture drains, and it's showing with the trap there. So you can see this is a really good example right here where we have the drains and how it comes down solid. That would be the solid and the water. And of course the gas, we want to come up to the top and then exit through the top of the building. And all of this, you can see that these come down here, and we want all of this to vent. The fixture drain serves a single fixture trap and is sized based on the particular fixture load. Most codes allow a removable joint of a trap to serve as a cleanout for a fixture drain, which this is what we're going to be doing in lab. A floor drain or shower drain with a removable strainer can serve as a cleanout for a fixture drain. So here's an isometric view of a fixture drain. So we can see that it drains down this way and it's flowing down here, and this will connect to a fixture branch, horizontal branch waste stack, or building drain. And then you can see up here we have the waste arm, and the fixture drain can be vertical or horizontal. So it can go down, or of course this would have to be pitched. And this piece here is showing that it goes up and vents. The fixture branch is a drain pipe that connects more than one fixture drain to a horizontal branch or a major segment of a DWV system. So here we have an isometric view of a fixture branch. So we can see here we have the fixture drain. Here this connects to the horizontal branch, and this is our fixture branch. Right here is our clean out. We have a fixture drain, and of course you can see that this fixture branch, again, this can be horizontal or vertical. And here we have, this would be a drain, this will be a drain coming into your fixture branch, and then here's your vent, and that would go out to the roof. The horizontal branch is a drain pipe that connects horizontally to a major segment of a DWV system. It can either connect to a waste stack or a building drain that connects more than one fixture drain or a fixture branch to a main segment of a DWV system. So here we have an isometric view of what a horizontal branch looks like. So if we start up here, here's a fixture drain, here's a fixture drain, they're coming into fixture branch, they're going down, here's your clean out, these are coming down to a horizontal branch, and of course we have a fixture drain coming up here, going into the horizontal branch, and the horizontal branch can connect to either a waste stack or a building drain. An individual vent serves as one fixture trap and is a vertical extension of a drain. It must be at least half the diameter of the drain it serves, but no smaller than 1.25 inches. So here's an isometric view of an individual vent. So we can see that the flow is coming down this way. This is our fixture drain. This is where our fixture comes in and drains, and this is a vent just for this fixture. So this individual vent can terminate to open air, or it can connect to other vents. A branch vent serves as a vent for a horizontal branch and connects to vent stack or stack vent. A branch vent is sized based on the size of the horizontal branch, the drainage load of the horizontal branch, and the distance it travels. Here's an isometric view of our branch vent. So let's start up here. So this connects to a vent stack or a vent, right? This can be horizontal or vertical, and this is our branch vent. And when we come down here, we can see that this is our fixture branch. So we have more than one fixture hooked up to this. We have an individual vent, and then these are coming in to the branch vent. A circuit vent is a branch vent that is not typical with other standard branch vent types and has specific code regulations. Single-family residential construction typically does not use battery configurations due to the minimal number of fixtures located within one room. So here's an isometric view of what a circuit vent looks like. So we could see here, this is where it's going to connect to the vent stack. This here is your circuit vent because it goes from here down. And this connects to a horizontal branch before the last fixture. So here's our last fixture before the clean out. And here we have our horizontal branch. And these can be whatever fixtures that we want. This must have a relief vent. And you can see as you come down, this hooks up with your horizontal branch. The loop vent is a circuit vent that is installed on the top floor of a building or highest branch interval. All sizing and code regulations are the same as those for a circuit vent. So keep in mind this is only for the top floor of a building or the highest branch interval. So the loop vent, it connects to the vent stack, and you can see where it comes up here. And this, just like the circuit vent, connects to horizontal branch before the last fixture. So here's our last fixture, here's our clean out, here's our horizontal branch coming down through, fixture, fixture, fixture. And you can see that the difference is that this doesn't have the relief vent like the circuit vent did right here. A relief vent is required when a waste stack transitions from vertical to horizontal. The most common relief vent is one serving a battery of fixtures. A relief vent serving a battery of fixtures is sized based on being half of the diameter of the horizontal branch, but as with all vents, it cannot be less than 1.25 inches. Here's an isometric view of the relief vent. So we saw one like this before in the circuit vent, right? So let's start up here, and we can see it right here. We have our relief vent, and this connects to our circuit vent, which would be before the last fixture here, coming up and then over. And then the side view of it, so we can see where the relief vent is here, connects to the waste stack below an offset, and that would be dictated horizontal offset to the waste stack, and it connects to the waste stack above the offset. So you can see the offset would be somewhere in here, and that's where it is. Wet venting is a piping arrangement that uses a single vent for more than one fixture. The vent is also used as a drain, right? So this vent is used as a drain also. The wet vented portion of the drain must be sized using a chart in a codebook relating to the actual fixtures and their DFU values. So here is an isometric view of wet venting. So when we look in here, you'll see that this is slightly different than the other ones. Here's our sink, and even though this is coming out as a vent here, this is our wet vent area because we're collecting the wastewater from the bathtub, and there's also wastewater from the toilet that's coming down here, but these also act as the vent at the same time. So we're starting up here. This can connect to any portion of the venting system, or it can go right out through the roof. And this is the vent for the entire bathroom group. So again, for the sink, the bathtub, the toilet, this wet vent acts as the entire vent. Coming down here, this branch, it can connect to any portion of the drainage system. And if you see this note here, the toilet typically must be downstream of other fixtures. And I think that's kind of obvious why, right? Because if everything is coming through here, you wouldn't want your toilet, and if there's a chance of it backing up, you don't want it to pass through your bathtub. And the same with your sink. You wouldn't want your toilet up here, and then your sink, and then your bathtub, because then all of your waste from your toilet would have to pass through there, and that's just uh, not good. Island venting. It's used to service kitchen sinks located away from a wall or other area where a vent cannot be a continuation of the drain. A venting device known as an air admittance valve is placed in the need to install an island vent for many installation applications. We don't have this in lab, but you'll see this sometimes too, not just in kitchens, but in areas of buildings where it would be impossible, almost impossible to connect to the vent system. So here we have the island venting, and you can see that this is pretty significant for what we're doing. This gets into a lot of detail and specifications that you're not going to really have to concern yourself with for this class. So the layout for a DWV system is typically the first process completed. Theoretical methods that determine sizing are based on the rate of flow that a fixture discharges wastewater into a drainage system. A code book provides the charts to indicate the DFU value of typical fixtures and particular pipe sizes. All horizontal drains must have adequate slope. Right, we don't want the stuff to back up. We want to make sure that when we flush a toilet that it goes downhill. We don't want to worry about this not going downhill. That's just not good. A separate chart in the code book is used pertaining to where an installation occurs based on the segment of a system. Waste stack and building drain are both major segments of a DWV system that receive discharge from fixture drains and branches that they serve. And we covered this in previous slides. A fixture drain installed above ground is sized based on the particular fixture served. A code book indicates the minimum drain and trap size that can serve a particular fixture. So we're going to look at the code book for this. That's not going to be something that we're just going to pull out of thin air. We're going to look at the code book. Though a drain cannot be smaller than 1¼ inches, which we've said multiple times, in diameter, most codes dictate that the smallest drain size buried below ground is 2 inches in diameter. So here we have fixture drain sizing. If we check this out, so a lot of these things we already covered. So up here we have our individual vent. This would be our sanitary T, which catches the two. This is our vertical fixture drain, a long radius. So this isn't going to be a quick 90. This is going to be a long 90, and it's flowing out that way. So this portion of a fixture drain is also known as a waste arm and can be the same size as the trap. So here's our waste arm here. So the waste arm goes from the trap up to the vertical fixture drain. And the trap distance is in figure 1338. In this instance, the trap here can be removed and used as a clean out. So here we have another fixture drain sizing. This is a toilet example. It's an isometric view. So here, this is the closet flange. This is where our toilet is going to connect to the floor. The maximum distance that we can have is 2 feet. And this can be a standard 90-degree fitting, right? We're not going to have enough room in a floor in order to put the long sweep. This needs to be a minimum 3-inch diameter, and this is your fixture drain. Here we have the trap distance between the two, and we're going to have our vent down here, and flow is going out that way. And here you can see in this example that the toilet can be removed to serve as a clean out as well. Fixture branch and horizontal branch sizing. To calculate the DFU load the branch serves. Some branches connect to a waste stack and some connect to a building drain. We talked about this before. A separate chart in a code book is used for each connection location. So again, don't wing it, go by the code book. A cleanout is installed in various locations in the system, and the maximum distances are dictated in the code book. Here we go again. It typically cannot be more than 100 feet apart. So here we have a fixture branch and horizontal branch sizing. And here you can see here we have the fixture drain, an individual vent. We have a clean out here, and this is all coming down to the horizontal branch. Here we have another one with a trap, and this is coming down. And right here we have the vent. Here's our fixture branch coming down. Here we have another vent. This is our fixture drain coming down to our fixture branch, coming down to our horizontal branch. Here we have another clean out. Waste stack sizing. If a waste stack transitions 45 degrees or greater from true vertical, special regulations are used to size the waste stack. A relief vent is not required on a vertical offset if there are more than 4 branch intervals above the offset area. This sounds like a lot. If a relief vent is required, the upper and lower portions of the offset area must be vented separately. So what's that look like? Here's a side view of a horizontal offset. So here we have our top floor. This is our stack vent coming up through the roof. This is our waste stack. This is our horizontal waste stack offset. Here, you can't have more than 4 branch intervals. And again, here we have the base of the waste stack coming down here, and the flow going out for the building. Here's a side view of a vertical offset. So here we go with our branch intervals, 1, 2, 3, 4. But this 5th branch interval is below the top of the stack. Here we have the protected zone is 2 feet above the vertical stack offset. So this is our stack offset, which is about 45 degrees. So we need to be 2 feet above that. And again, we have to be 2 feet below the vertical stack offset for this one. So here's our offset. We have to come down 2 feet. If any connections are within the offset area, the stack must be vented with a relief vent or sized as building drain. So we went over relief vents in previous slides. The branch interval, so if there's more than 4 intervals, they must be below the top of the stack. And again, here's our waste stack, and then here is where they give an example of that. Building drain and sewer sizing. A building drain and building sewer are 2 different segments of a system. Some codes may allow for testing requirements of building sewer to differ from testing a building drain. Most codes require building drain to have more rigid pipe specification than building sewer. If a vent stack originates at the building drain, a protected zone is created and the connection must be within 10 pipe diameters from where the waste stack connects to the building drain. So if a vent stack originates at the building drain, a protected zone is created and the connection must be within 10 pipe diameters from where the waste stack connects to the building drain. So keep that in mind. Here's a side view. So here we have our waste stack, we have clean out, here's a vent stack, the flow is coming out here, here's a clean out, here's a clean out, 100 feet, maximum distance between the two of them. Some codes may not require clean out at the base of a vent stack. Clean out required at junction of building drain and building sewer, which is right here, and we talked about that previously. Here's a side view. So here's our exterior wall. 2'6" minimum, 10-foot maximum for the clean out serving the building sewer, and the building drain is coming in here. And you can see here, it's required that a sleeve goes through the wall for the pipe to run through. So the pipe does not come in contact with the wall. There's a sleeve that acts as protection, and then the pipe goes through that. Stack vent and vent stack sizing. Many codes dictate that a stack vent must be the same size as the waste stack. So the stack vent must be the same size as the waste stack. Other codes dictate that a stack vent and the vent stack are sized based on the length they travel and the total DFUs that they are responsible for discharging. They cannot be less than half the diameter of the waste stack or less than 1.25 inches, right? This or less than 1.25 inches thing seems to be coming around a lot. So here's a side view of what that looks like. So we have our waste stack, here's a clean out, vent stack, here we have a clean out. Some codes may dictate the height above the floor necessary for the clean out. These come down, here's the building drain, And on this side, we can see that we have a waste stack, vent stack, clean out, clean out. The biggest difference is this one has the 45, this one does not have the 45, but this must connect vertically. So here we have another picture. Here's our roof, here's our stack through the roof, here's our stack vent. Size based on the larger of two sizes, and verify that it does not have to be increased due to frost closure regulations. So this vent stack can transition horizontally. Individual vent sizing. Sizing an individual vent is primarily based on being half the diameter of the drain it serves, but no less than 1.25 inch diameter, right? Again, half the diameter of the drain it serves, but no less than 1.25 inch diameter. Some codes dictate that a vent must increase one pipe size if it travels more than 40 feet. This is important, right? We have to check our codes. So here we have a side view of what that looks like for the individual vent sizing. Branch vent sizing. A branch vent is sized based on the diameter of the drainage branch, the DFU value it is responsible for discharging, and the length that it travels. The minimum size branch vent cannot be less than half the diameter of the drain it serves, but no less than 1.25 inches in diameter. And again, here we have the branch vent sizing. Circuit and loop vent sizing, so they're classified as branch vents. They're sized according to their own piping allowances, and it refers to the isolating portion of a DWV system to create its own smaller system. We went through this like for a bathroom or something like that. If it doesn't have an individual branch that you can do with the circuit with the relief on it. Wet vent sizing. No fixture can be installed downstream of a toilet without being individually vented. So if you go back to the diagram that we had, it had the sink, the tub, and then the toilet, right? And not the toilet, the sink, and then the tub, but the toilet is the last one. Must be at least half the diameter of the drain it serves. Any fixtures or branches that are not part of a wet venting arrangement must connect downstream of the wet vented configuration. Air admittance valve sizing. So this is what we talked about in some kitchens. They allow air into a DWV system without sewer gas to escape into the occupied area. A relief vent is required on a horizontal branch served with an AAV relating to the individual branch and vents. AAV sizing is based on the size of the vent using the same codes as those for individual and branch vents. The island vent sizing. A sink located away from walls may be piped with an island vent. Most codes limit island venting to sinks and lavatories. Most special DWV designs, like the island vent, require approval from code officials. The maximum trap, the maximum distance that a trap can be from a vent is known as the trap distance. The trap distance is determined along the pipe route as opposed to simply measuring the distance from the vent to the center of a fixture. Because think about it, the pipe is going to take a different route, right, than what the pipe will. The IPC and UPC differ pertaining to the trap distance. So again, this is going to come down to where you're at and what the code official says. Many private disposal systems utilize pumps that discharge wastewater, also called effluent, to a drain field and do not require a distribution box. Conventional septic tank systems utilize the ground to absorb wastewater that flows from a septic tank by gravity. In summary, a plumber must focus on being the front line of protection of the public against harmful sewer gas. That's why we have traps and vents. Segment identification of certain drains and vents is required to properly size a DWV system. DWV codes vary from each region, state, and local area. A drainage fixture unit, or DFU, is the basis for sizing a DWV system. The codebook is required to locate the allowable DFU load on a particular pipe size. The minimum trap size is dictated by code and located in the appropriate table in a codebook. Fitting use is based on the flow position of a drainage system. The three flow positions of a drainage system are horizontal to horizontal, vertical to horizontal, and horizontal to vertical. Cleanouts are required based on changes in direction and distance, and at the base of a stack. Slope is required on a horizontal drain and varies based on pipe size. A vent is sized based on the drain size, the distance it travels, and its classification. Most codes dictate that one 3-inch minimum vent be extended to open air. Wet venting is a drain allowable fixtures being used and to vent for other fixtures. And of course, we have the green checklist. Never allow harmful chemicals or toxic substances to enter a septic system. Pollutants that enter a septic tank can eventually drain into the ground. The groundwater can become polluted by chemicals or toxic substances that enter the ground through a septic tank. That's it, and see you next time.